FastMCP3 employs a declarative state management system through action primitives that modify application state via immutable transformations. The framework exposes 5 core action types: SetState, ToggleState, AppendState, PopState, and ShowToast, each implementing a distinct state mutation pattern while maintaining referential transparency. We will now examine how these action primitives are initialized and composed to manage application state, with particular attention to their parameter signatures and immediate execution semantics. From Prefab UI, actions import SetState, ToggleState, AppendState, PopState, ShowToast. Hash set a value. SetState count 42. Hash toggle a Boolean. ToggleState expanded. Hash append to a list. AppendState items, name, new item. Hash remove by index. PopState items, 0. Hash show a notification. ShowToast done, variant equals success. This code demonstrates FastMCP3's state management actions, which provide a declarative way to modify application state without direct DOM manipulation. The 5 actions shown represent the core state manipulation primitives: SetState for direct value assignment, ToggleState for Boolean flipping, AppendState for list additions, PopState for list removals, and ShowToast for user notifications. The design follows a functional reactive programming pattern where state changes are expressed as immutable operations rather than imperative mutations. Each action takes a state key and either a value or transformation rule, with ShowToast being the exception that handles UI feedback. This approach enables predictable state management and simplifies debugging by making state transitions explicit. The trade-off here is between simplicity and flexibility. While these actions cover common state operations, complex state logic would require chaining multiple actions or handling it in backend tools. The pattern works well for UI-driven state changes, but assumes the application follows a unidirectional data flow model, where state changes trigger reactive updates. Let's break it down. From Prefab UI, actions import SetState, ToggleState, AppendState, PopState, ShowToast. Imports 5 action classes from the Prefab UI. Actions module: SetState for direct state assignment, ToggleState for Boolean state flipping, AppendState for adding to state collections, PopState for removing state elements, and ShowToast for displaying temporary notifications. These provide the basic UI state manipulation and feedback capabilities used in the current context. SetState count 42. Sets the state variable named count to the integer value 42. This is a direct assignment operation that updates or creates the state entry with the specified key-value pair. Hash toggle a Boolean. ToggleState expanded. Calls the ToggleState function with the string argument expanded, flipping the Boolean state associated with the key expanded between true and false. Hash append to a list. AppendState items, name, new item. Calls AppendState to add a dictionary, name, new item to the list stored under the key items. The operation appends the new item to the existing list without modifying other entries. Hash remove by index. PopState items, 0. Calls PopState to remove the item at index 0 from the collection named items. Hash show a notification. ShowToast done, variant equals success. Displays a success notification with the message done using the ShowToast function. The variant parameter is set to success to indicate a positive outcome. FastMCP3's state management revolves around 5 declarative action primitives that treat state as immutable data. Each action, SetState, ToggleState, AppendState, PopState and ShowToast serves a distinct purpose while adhering to the same functional reactive pattern. They operate on state keys, either assigning values directly, flipping booleans, modifying collections, or providing UI feedback. The design enforces referential transparency by expressing state changes as operations rather than mutations, which simplifies debugging and state tracking. The trade-off is intentional. These primitives cover common UI-driven state operations, but delegate complex logic-to-action chaining or backend tools. This works because FastMCP assumes a unidirectional data flow where state changes trigger reactive updates. The ShowToast action stands out as the only one handling UI feedback, while the others focus purely on state transformation. Together, they form a cohesive system where state management remains predictable and explicit, even if it requires multiple actions for advanced scenarios.
SetState etches 42 into stone, while ShowToast broadcasts success to an empty server room.